Hi, thanks for joining me today. I've got an integral theorem which we want to either prove or disprove. So this is what we have. We have a function f of x which is even, so that means that f of x equals f of minus x for all x. And what we want to do is either prove or disprove the following equality. So the integral from minus a to a of f of x divided by 1 plus e to the x dx equals the integral from 0 to a of f of x dx. And here a is just some arbitrary real number. Okay, so if you want to have a go at this problem, pause the video now and give it a go for yourself, and I'm going to jump straight into a solution. Okay, so what's pretty remarkable about this is in fact it's a true theorem, so you can prove the equality holds. So this integral here does in fact equal the integral from 0 to a of f of x dx. And what's really surprising about this is the fact that all we know about f is that it's an even function, and we don't really know any information about a apart from the fact that it's a real number. So it seems like this isn't going to be true because you've got this weird 1 plus e to the x in the denominator, and it feels like that's going to mess things up, at least for one particular value of a, or perhaps some particular even function f of x. But in fact that's not the case, and we can show this equality is true, so the kind of statement is true. Okay, well, how we're going to do that is firstly define this integral here. We're just going to call it I, and what we want to do is show that I equals the integral from 0 to a of f of x dx. The first thing we're going to do is a very simple u substitution, and whenever you have a u substitution for an integral where the limits are minus a and a, the kind of standard one is just to do let u equal minus x, like so. And then of course from that we get the du is equal to minus dx. Okay, so if we just go and plug everything in, we get the integral from, well, when x is minus a, we get u is minus a, so a. When x is a, u is minus a. And now f of x is just f of minus u, but remember, f is an even function, so f of minus u is the same as f of u. Okay, and on the denominator we're going to get a 1 plus, and now e to the x is e to the minus u. So 1 plus e to the minus u, and then dx is a minus du, so I'm going to put the minus sign here, and then put du there, like so. So I is equal to this thing here, but we can actually do a little bit of simplification. Because we've got this minus sign here, we can actually swap the limits of integration. So if I get rid of the minus sign and then swap the limits, so this thing now is minus a, and this thing here is just a, like so. So we've shown that I equals this thing here, and this looks quite similar to what we have up here. So I'm just going to swap all the u's for x's here, and that's just like that's fine because u and x are just dummy variables here. So this is just the integral from minus a to a of f of x divided by 1 plus e to the minus x dx, like so. So we've shown that I is equal to this guy here, and this thing here looks very similar to what we had at the start, except the only difference is before we had an 1 plus e to the x in the denominator, but now we have 1 plus e to the minus x. So that's a small but subtle difference, but those two quantities are exactly the same. Well, what we can do with this one here is just look at the thing that we're integrating and just multiply the top and bottom of that fraction by e to the x. So we get an e to the x on the top, and then if you multiply the bottom by e to the x, this 1 times e to the x is going to become an e to the x. And e to the x times e to the minus x, well, that's just 1. So our denominator is e to the x plus 1, which is the same as the denominator here. So we've got I equals this guy, but it also equals this guy. And perhaps if you've seen these sort of integral tricks before, you can perhaps guess what we're going to do next. We're actually going to add this thing to this thing. So because these guys are the same and they're both I, when I add them together, on the left hand side I'm just going to get 2i. And on the right hand side I'm just doing this guy plus this guy. And because they're both integrals with the same limits, I can just bring it all under one integral. So it's an integral from minus a to a of this thing plus this thing. So f of x all over 1 plus e to the x plus e to the x times f of x all divided by 1 plus e to the x, and that's dx, like so. Okay, so just adding this thing with this thing, but now we can bring everything under one common denominator, so we get a 1 plus e to the x as our common denominator. So on the top we're just left with f of x plus e to the x times f of x all over 1 plus e to the x. But now, have a look at this, we can factor out an f of x from the numerator, and the numerator is just f of x times 1 plus e to the x. But then that 1 plus e to the x in the numerator will cancel with the 1 plus e to the x we have here in the denominator. So all in all, this guy here is just the integral from minus a to a of f of x dx, like so. And we're almost done. Remember, again, we're going to use the fact now again that f is an even function. So that means that its integral from minus a to a is the same as twice its integral from 0 to a of f of x. Okay, and that's just one of the properties of even functions, kind of by symmetry. Its integral from 0 to some point is going to be the same as that some point to 0. So essentially this thing here is just double the integral from 0 to a. Okay, so we get this thing, this 2i is equal to 2 times this thing here, and of course just cancelling the 2's gives us the result we want. That I, this integral up here that we initially started off with, is equal to the integral from 0 to a of f of x dx. And that's really, really cool. You started off with this integral which involves an e to the x, and we've kind of gotten rid of that and just shown that it only depends on a and f of x. And f and a can be arbitrary, so a would be an arbitrary real number, and f can be an arbitrary even function. And this is all really, really cool. And yeah, this proves a theorem, which I think is really, really interesting, because when I first saw this prove or disprove, my intuition told me that this can't be true. So I tried to find some counterexample. So find some particular even function, then I was like, oh, this isn't really working. Let me try and find a particular value of a, and that just doesn't work because it, in fact, is a true theorem as we've proved here. Anyway, I hope you have enjoyed this integral video. Thank you for watching. I'll catch you in the next one. Have a great day.